Welcome to Module 3 of the Introduction to Organic Dairy Production course. Module 3 will focus on organic soil management. Today's module will be presented by Heather Darby of the University of Vermont Extension. This module will outline the basic principles of organic soil management. Healthy soils are the foundation of organic production practices and organic production success. A healthy soil will not only produce high-quality forages and crops, but will also contribute to producing a healthy and productive herd. During this module, we'll cover characteristics of a healthy soil. We'll have a strong focus on the importance of soil organic matter, types of soil organic matter, and the impact that soil organic matter has on nutrient cycling and availability, soil tilth, and disease suppression. We'll end the module with an introduction about how to build a healthy soil and also an introduction to monitoring soils on the farm. There are several required readings for this module, such as Digging In, a nutrient management course for farmers, Organic Soil Fertility, an e-extension article, and Managing for Soil Organic Matter, also an e-extension article. Let's start this module first by talking about the characteristics of healthy soil. What does a healthy soil look like? First, a healthy soil should have sufficient but not excess nutrients. Sufficient nutrients to support healthy crop growth, but not excess nutrients that could potentially actually harm the crops, the environment, or the livestock. Secondly, a healthy soil always has good tilth. That means if you're actually working the soil, it's easy to work with a piece of tillage equipment, and that it also has good tilth so that it helps drain water and also have sufficient depth. Healthy soils should have sufficient depth so that the roots of the plants can explore the entire soil profile. And again, a healthy soil should also provide storage of water during dry periods, but also during wet periods should allow the water to drain freely. Of course, a healthy soil should also be free of any harmful chemicals that might be harmful to the plants and also to the animals. Healthy soils should have low populations of plant disease as well as parasitic organisms. And opposite of that, they should have high populations of organisms that help support healthy plant growth. Of course, in a perfect healthy soil, we would have low weed pressure. A low weed pressure is common in soils that are well balanced in nutrients. A healthy soil is also very resistant to being degraded. So if we receive 6 or 7 inches of rainfall at one time, a healthy soil should help to keep the soil in place. And a healthy soil should also be very resilient. Let's talk about the soil components. Soil is a mixture of minerals, organic matter, air, and water. And ideally, in a perfect world, in your soil there should be 50% solids. And that's a split between minerals and organic material. The organic material is generally a very small portion of the 50% solids, and on average is around 1 to 5% organic matter. And this organic material comes from plant, animal, and other organism residues. Now the other 50% of the space in your soil, and of course this is between the soil particles, is what we call pore space, and that should be filled with air and water. So a healthy soil should have plenty of room for air and water, have as much organic matter as possible for that system, as well as having the sand, silt, or clay that is the parent material of your soil. Now we're trying to create healthy soils, and in order to do that we really have to look at the soil as a whole system. We can't just look at the chemical aspects of the soil, or just the biological aspects of the soil, or just the physical aspects of the soil. We actually have to take all three of these aspects, the physical, chemical, and biological, and try to enhance all of them. They all work together closely, and focusing on one sometimes is at the detriment of the other. And you can't have a healthy soil unless we're paying attention to the physical, chemical, and biological aspects of the soil. There are many aspects of soil that we could spend our module talking about. Soil is very complex, but we're going to choose to focus our time on discussing soil organic matter. Soil organic matter is truly at the heart of soil health and has many influences, important influences on the physical, chemical, and biological properties of the soil. And soil organic matter is essential to improving soils, especially under organic management. Now, again, organic matter influences a vast number of soil properties. It influences nutrient availability, soil aggregation, and therefore influences infiltration and drainage. It influences water storage. It also influences diversity and activity of soil organisms. It provides that deep dark color to soil, which actually will help heat the soil up in the springtime especially. It also can play a role in the presence of many growth stimulating compounds that actually help the plant grow and sometimes helps the plant fight off disease. And then lastly, it's very important in many global cycles such as the carbon cycle, the nitrogen cycle, and the water cycle. All of these soil properties and many more are influenced by soil organic matter. So it is a very important aspect of your soil. Soil organic matter can actually be broken up into different fractions. And so sometimes we classify these into three general types: the living organic matter, the dead organic matter, and the very dead organic matter. The living organic matter is composed of many of the organisms, or all of the organisms, living organisms in your soil. And there certainly is a diversity of organisms, or should be a diversity of organisms, living beneath your feet. This is often termed the soil ecological community, and we have major soil biota groups that are categorized by size. There's the microflora that are, for example, the bacteria, the fungi, and the algae, and the microfauna, which are a little bit bigger, the protozoa and nematodes, and then the meso and macrofauna, which includes earthworms and arthropods such as insects, spiders, and mites. But overall, there should be a large diversity of living organic matter in your soils. The dead organic matter is what is recently dead soil organisms and crop residues that will actually provide the food for the living to live and function in the soil. And often this is called active or particulate organic matter. So the living are these groups of soil organisms, and the dead are recently dead soil organisms as well as crop residues, and the dead provide food for the living. Here's a photograph of what dead organic matter looks like, and you can actually see the plant material still visible through a microscope. You can actually see pieces of leaves and maybe a few roots as well. You can see it's light in color. It's being decomposed, so it's recently dead. Now the very dead is well decomposed organic materials. So it was living, and then it was dead, recently dead, and then it was decomposed by the living, and then it becomes very well decomposed organic materials, or the very dead, and this is also called humus, and humus contains very high amounts of negative charge. That's one of the roles it plays in your soil, is to provide soil charge. Here's a photograph of the very dead organic matter, and you can see how dark it is. It's been very decomposed. You cannot see any plant parts, such as the roots or leaf tissue, and has been utilized by the microbes already. And you can see that this most likely gives the dark color to your soils, and again, it also provides a negative charge in your soil. As we mentioned earlier, soil organic matter on the whole is really just a small fraction of your soil. And organic matter itself usually makes up 1 to 6% of the total soil mass, and of course for some it can get even higher than that. Now within the soil organic matter, we just talked about 3 types of organic matter: the living, the dead, and the very dead. And if we break those fractions up, you can see that the very dead makes up the largest portion of your organic matter. And you can see that the living and the dead make up a much smaller portion. So the very dead is about 60 to 80% of all the organic matter in your soil, and the living and the dead are 10 to 20% of the total soil. Even though soil organic matter makes up a small portion of the total soil, it's very important, as we've already stated. And all 3 types, the living, the dead, and the very dead, play very important roles in helping produce high yields and healthy crops. Next, we'll talk about how soil organic matter influences both soil properties and functions. We'll start by talking about the influence of soil organic matter on soil chemical properties and nutrient availability. On an organic farm, most nutrients are released to the plants through organic matter. Organic farmers rely heavily on organic matter decomposition to provide nutrients to their plants. And this process is essentially looking at the transformation of one type of organic matter to another. So, as dead organic matter is decomposed by the living organisms, nutrients are transformed into forms that are available to plants. So again, we have to have the dead, which is recently dead organisms and crop residues that are further decomposed by living organisms in the soil, at which time nutrients are made available to plants and also to other living organisms in the soil. One great example of how nutrient availability is impacted by soil organic matter fractions is through the nitrogen cycle. And the nitrogen cycle is one of the only nutrient cycles that's 100% biologically driven. And so it's a very important cycle to understand, because nitrogen doesn't come from minerals or rocks. It actually comes solely from a biological environment, and it's also heavily influenced by the biology in the soil. So let's talk about this example so that you can better understand soil organic matter and the nitrogen cycle. So nitrogen can come from a variety of sources. Nitrogen can come from livestock manure. It can also come from the roots of legumes, where there's essentially nitrogen-fixing bacteria that decompose and release nitrogen. And of course, nitrogen can also come from plants and decomposing plant residues. And we call this the soil organic nitrogen. And soil organic nitrogen is basically found in the dead soil organic matter. So as cow manure and decomposing residues become prevalent in the soil, they contain a portion of nitrogen. Now, in order for that nitrogen to be released from the soil organic matter, there needs to be a series of decomposition steps for that nitrogen to become available to your plants. Essentially, a plant root cannot just start taking up nitrogen from the soil organic matter. It has to be broken down into plant available forms, and this happens through a variety of steps. So first, primary decomposers begin to work on the soil organic matter, and these are different bacteria and fungi. And through that step, we get the production of ammonium. This is called ammonification. Now, the ammonium can be taken up by the plants, although it's not the preferred source of nitrogen. Ammonium is generally further decomposed into nitrates, and again, this step right here can only be done through a set of bacteria called nitrifying bacteria. Once the nitrates are released by the nitrifying bacteria, the nitrates can then be assimilated by plant materials. But you can see from the nitrogen cycle that soil organic matter must be decomposed to release the nitrogen so that nitrogen can be assimilated by the plants. As mentioned before, the very dead organic matter also plays a role in influencing the soil chemical properties. The chemical characteristics of a soil go beyond just nutrient availability and also include pH and the cation exchange capacity, or the CEC. And the cation exchange capacity refers to a soil's ability to hold on to nutrients. Here's a schematic that shows the cation exchange capacity. And as I mentioned before, your soil should have a negative charge, and you can see the negative charges on this photograph. Now, the negative charge of the soil can come from two different aspects. It can come from the dead soil organic matter, and it can also come from the clays in your soil that have negative charge. So if you have a sandy soil, sands do not have a charge, and therefore sands do not hold on to nutrients very well because there's no negative charge. When soil organic matter is built in a sandy soil, you can create a negative charge in those soils and increase the cation exchange capacity. So again, the cation exchange capacity is the ability for your soil to hold on to positively charged nutrients. As you learned probably early in science class, positives are attracted by a negative. So your negative soil should hold on to positively charged nutrients or cations. And as you can see in the schematic, these include hydrogen, calcium, magnesium, ammonium, sodium, and potassium. So the more charge in your soil, the greater ability it has to hold on to these nutrients. And you can increase cation exchange capacity in your soils by having lots of soil organic matter, or more specifically, the dead organic matter. So most of the nutrients in our soil are generally in sufficient quantities to accomplish our objective, and mostly we're trying to increase the nutrient cycling and nutrient availability to the plants. But just because there's lots of nutrients in the soil doesn't necessarily mean that they're always going to be available to the plant. Again, there's more to managing soils than just focusing on the biology. And one of the key components to nutrient uptake is, of course, the chemical solubility of that nutrient that the plant requires. And this solubility is highly dependent on the soil pH. So before moving on, we should touch on the pH of the soil. And you can see if too many of your negative charges become surrounded by hydrogen or aluminum, then your soil pH can be very low. And by low, I mean below 7. 7 is considered a neutral pH, and below 7 we consider that acidic, and above 7 we consider that an alkaline soil. And so if your soil charges become too full with hydrogen or aluminum, you could be reducing the pH of your soil. And here's a soil pH interpretation, essentially showing 7 is neutral. Anything below 7 is slightly acid to strongly acid, and above 7 being mildly alkaline or more alkaline. And usually the best range for most crops is somewhere between 6 and 7. Now, when you have acidic soils, you can run into a variety of issues. So again, too many hydrogens or aluminums on those negative charges can essentially bring up toxicity of different nutrients to your plant. So we can suffer from aluminum toxicity or manganese toxicity, and also calcium and magnesium deficiencies. So if your pH is too acidic, you can basically make some nutrients too available in your soil and other nutrients not available. When phosphorus is tied up, we generally see that in an acidic soil, but we can also see it in a very alkaline soil. And obviously in a very acidic soil, some of our microorganisms also do not grow very well. And if you're trying to fix nitrogen by your legumes, an acidic soil will also reduce the ability for those nitrifying bacteria to be present. And in a soil where the pH is too high, in an alkaline soil, you can also get nutrient deficiencies as well as some bacterial issues and diseases on certain crops. So how do you rectify a soil that has too many hydrogens on their negative binding sites? And again, generally the problem with too much hydrogen and aluminum is not necessarily because of something that you did to the soil. Many soils are just naturally high in those ions, and therefore, because of the parent material of your soil, you have a lot of hydrogen and aluminum. And for many farms, we must use a technique called liming in order to change the pH of the soil and get rid of some of those hydrogens and aluminums and create more calcium on our soil colloids. And so in order to create a soil where the crops can grow properly, we need to use agricultural lime. And of course, you need to check with your certifier to make sure that the source of lime that you're using is approved for organic use. But the basic principles are such that when you lime with a material like calcium carbonate, the calcium being a little bit stronger than the hydrogen, you can see these +2 versus +1, has the ability to essentially bump off the hydrogens through brute force and essentially kick them off your soil colloids, replacing them with calcium and increasing your pH. And then the byproduct, of course, is water and carbon dioxide. So in order to get plant nutrient availability at its best, you need to make sure that the pH of your soil is rectified as well. In order to get healthy soils and healthy plant production, pH plays an important role in nutrient availability, and it's important to make sure that your pH is in that proper category, somewhere between slightly acidic and slightly alkaline. Now we're going to talk about how soil organic matter influences soil physical properties and soil tilth. The physical properties or characteristics of your soil include both the color, the structure, and the texture. Now, of course, the texture of your soil is really something that your soils are born with. It's very difficult to change the texture of your soil, but you can work on changing both the color and the structure. So the texture depends on the amount of sand, silt, and clay. And of course, the texture will have a huge influence on the physical properties such as soil fertility and also cation exchange capacity, as we mentioned earlier. It can also affect the water holding capacity. For example, clays generally hold more water than a sandy soil. Clays also have negative charge where sands do not, so they will hold more nutrients. And of course, some soils are prone more to erosion and also are easier for the roots to penetrate, etc. So texture is, again, something that your soils are born with, but structure and color can be influenced. And one of the primary ways to influence and improve the structure, overall structure of your soil, is through organic matter management. So again, the soil structure that we're looking for is something that includes soil aggregates, which we'll talk about in a second, which are surrounded by plenty of air and water, so plenty of pore space. So as you can see here, we have a photograph of pore soil structure, and essentially you can see really if it rained, there would be no place for the water to move. It would be very difficult for water to drain from this soil. And you could see that probably there would be a lot of runoff. Lack of air space and also water space also creates problems for roots. Where would the roots grow through here? It would be difficult for roots to grow. And also, where will the microbes live? So soil structure is not just important for water movement, but it's also very important for the roots of your plants to gain access to water, air, and nutrients, as well as for the microbes to have, and other organisms to have a nice place to live. Over to the right here, you can see a schematic of what we would consider good soil structure, where you have these soil aggregates surrounded by plenty of air and water space, and you can tell that a root system would have plenty of room to move through here, as well as microbes, air, and water. So what are these soil aggregates that I keep talking about? Well, essentially you have these minerals or solids in your soil. You have the clay and the silt and the sands. And in a dispersed state, they're just, again, particles. And if you think about clays, these particles just lay flat on top of each other, not creating much structure at all. And really, when these soil particles are glued together by microbes and microbial glues and other pieces of soil organic matter, they form what we call a soil aggregate. So we have soil organic matter, plant roots, fungal threads, bacterial gels, earthworm feces, etc., some of those forming glues, all binding together to hold these soil particles together, creating a soil aggregate, and those aggregates laying unevenly on top of each other, creating a good soil structure. Okay, so you don't just have soils in a dispersed state, just these soil clay and sand particles. You actually have those particles brought together and glued together into these aggregates that should be resistant to rainfall and also create a well-structured soil to allow for plant root and microbial growth. All right, so here's another picture of aggregated soil, and you can see when you get a rain, aggregated soil, they're not piled tightly on top of each other, so it allows for rain infiltration down and drainage down through the soil profile. Now, what often happens if you have poorly aggregated soil or very weak aggregates, so they're not held together by microbial glues very well, the minute you get a rain, you break up the soil particles and they're just laying on top of each other, and it creates this soil crust that we often see after major rainfalls. Once that soil crust forms and we get a rainfall, the water essentially just runs over the top of the soil, and therefore you have poor infiltration of rain. You can see how this soil crust or poorly aggregated soil would not allow for root penetration, and you can also see how there wouldn't be much oxygen in this part of the soil and would create issues for both the plants and the microbes. Again, just to hit this home one more time, you can see essentially how a poorly aggregated, poor structure soil would reduce airflow and water flow through the soil and also create issues for plant germination and growth. And whereas a well aggregated soil, you would get plenty of air and water down through the soil profile. Those have just been schematics, but here's a picture actually from two fields in Vermont. One field that was very well aggregated and another field that had poorly aggregated soil. This soil had been in continuous corn for many years. This is on a heavy clay, and this soil was in an excellent rotation, just coming out of a high biomass yellow sweet clover crop. And you can see that after 7 inches of rain, you can still see the aggregates on top of the soil here, very strong. The soil was already drying, and there was no ponding water, no erosion, no runoff, and you can see that plants would more easily be able to grow under this situation. Whereas in this situation, the soil aggregates were not strong at all and actually were further broken by the rainfall. And you can see as the sun comes out, this crust would become extremely hard and extremely difficult for water and for air to get into the soil, creating issues for plant growth. Now, again, this aggregates cannot be formed really without the living decomposing the dead, essentially, and therefore it's important to have living and dead soil organic matter to help create well aggregated and good tilth in your soils. Now, this also goes hand in hand with soil biology, because without the biology we can't create the aggregates, and if the aggregates aren't there, the life in the soil will not really be able to survive very well. You can see that we have soil aggregates here, and between those aggregates there's a nice home for the fungi and the amoebae, etc. So having well aggregated soil creates space and a nice home for the microbes in your soil. If we refer back to the nitrogen cycle, you can also remember that it's a soil microbial process that breaks down soil organic nitrogen from manure or legume crops into plant available nitrogen. And these soil microbes, not only do they need the proper pH, but they also need the proper air, moisture, and living space, as well as temperature, to be able to convert organic nitrogen to plant available N. So you need to have excellent soil tilth to be able to get nutrients to flow and become available in your soil. Alright, so hopefully you can see how all of these different properties of the soil, the biological, the physical, and the chemical, are starting to fit together. Now, from the biological aspect, there's also many important functions of soil organic matter that we can't cover today, and we can briefly cover what's termed disease suppression, or soil organic matter mediated disease suppression, the ability for soil organic matter to assist with the suppression of diseases in your soil. There are many examples of soil organic matter mediated disease suppression in the scientific literature, and many of these systems are actually studied by scientists because they have been observed by the farming community. So this is a real function of soil organic matter that's observed oftentimes by farmers and then researched by academics. So how does soil organic matter mediated disease suppression occur or happen? Well, there are different mechanisms, but the most general mechanism is something termed general suppression, in which the soil microbial life or soil microbial population or food web is enhanced. The enhancement of the microbial population causes severe competition against the pathogen or the pest in the soil. So most of the times the plant pathogen might be present in the soil because it doesn't have any competition for resource or nutrients. And when soil organic matter is added to the system, this generally enhances not only the microbial population but the diversity of the population. And because there's a diverse population, it basically has a better ability to compete than the pathogen. And just through competition for resources, the pathogen is outcompeted, leading to the suppression of disease or another pest in the soil. So by adding soil organic matter, you're able to increase the living aspect of the organic matter, creating fierce competition on any pests that may be in the soil. And hence, you may see suppression of plant pathogens. Another example of organic matter mediated disease suppression was in a sweet corn cropping system in Oregon. And in this system, sweet corn was grown not continually but in a very short rotation, generally with the same variety being used year after year. This is processing sweet corn. Also, this was in a system where there was not a lot of organic matter added back to the soils. And you can see there were high levels of root rot on the sweet corn in soils with low organic matter. And you can see in this example the control was a low organic matter system. In this experiment, the investigators evaluated the impact of adding high and low rates of soil organic matter to the sweet corn systems. And as you can see, when disease severity was high and low levels of organic matter were added to the soil, there was a very slight decline, but not significantly different in the amount of root rot. But when high levels of organic matter were added, you can see that there was a 20% decline in root rot of sweet corn. So essentially, adding some organic matter to this system increased the microbial population, and that microbial population was able to suppress the root rot disease by at least 20%. Now, in a system that was evaluated, Soil 2 it was called, where there was less disease to begin with and soil organic matter was added, even low levels created a 40% decline in root rot potential. So in a system where there's very little organic matter amendment and probably a low microbial population and not very diverse population, adding soil organic matter to those systems can increase the population and also may be able to help suppress some of the diseases that might be present in that farming system. As you can see, adding organic matter to the soil can have a major impact on many of the soil's functions, such as increasing biological activity, which again can help reduce soil-borne diseases and other pests. Adding soil organic matter can also help improve aggregation and release nutrients, as well as help improve the overall soil structure, all creating a healthy environment for plants to grow. So adding soil organic matter is really at the heart of creating a healthy soil, and understanding the types and functions of organic matter will now set us up to talk more about how do we actually increase and maintain organic matter in the soil. So what are some of the steps to actually building a healthy soil? And given the limited time of this module, we'll basically only be able to give an overview of these steps and be able to get into more detail in future classes. So the first step to building a healthy soil is, one, to add plentiful amounts of organic materials and a diversity, not just a lot, but a diversity of materials. You can see from the previous slides what role adding organic matter plays in many of the soil functions. So adding crop residues, whether it's cover crops or plow down of different crops, or manure or compost, adding some type of organic matter will help improve the health of the soil. And remember, when you're adding soil organic matter, you're also increasing the microbial life in your soil, because adding soil organic matter gives them something to eat. And the living needs to eat the dead. So remember, not all microbes like to eat the same thing, and that's why it's important to add various types and sources of organic matter. You want to create this diversity of microbes in your soil. So in order to do that, you need to supply a variable diet so that you are able to get as many types of organisms as possible. What types of organic matter are available to you? Well, you have on-farm sources as well as off-farm sources. And of course, the best thing is always to utilize on-farm sources first. These sources are coming from your farm, so they should already be certified organic. In the use of compost, you may check with your certifier on rules and regulations of using compost. So again, on-farm sources, you have crop residues. You have green manures, or those crops that you're plowing under. You should have livestock manure if you're on a dairy farm. You may be using that manure raw, or you may be composting it. And again, those are two different types of materials. You could have cover crops, and then there's other wastes and compost. If you have other types of livestock on your farm, then you may have other materials available to you. Or if you're processing milk on your farm and you have whey, etc., there may be other sources of organic matter. The other sources of organic matter that you may have access to could come from off-farm sources. And again, this may come in the form of compost produced on another farm or through another industry. It may also come in the form of lime or wood ash or other materials. If you are going to import other forms of organic matter onto your farm, you need to make sure that you check with your certifier to see that these are approved through your certifying agency before you do so. Now again, there are lots of choices of organic matter, but what you end up using on your farm, again, will really be based on the availability of those materials. Many of your on-farm sources you find that you don't have enough of for your land base. You may feel you need more manure, or you may feel you're deficient in some certain nutrient or type of organic material, and you may feel that you need to import materials from off-farm. And once you begin to think about what nutrients or what types of organic matter are required, then the next thing to think about is if they're approved organic, and what are the costs of those amendments. The other thing we always need to think about is the nutrient content and the nutrient availability of these amendments. So there's lots of choices. We need to add plentiful amounts, but we need to have a diversity. And part of that diversity is knowing what's in the material. what's the nutrient content, and what is the carbon to nitrogen ratio? How much nitrogen is in these materials that we're using? And then again, what's the form of material? How are you going to apply it? Is it liquid versus coarse? And so just knowing what you're adding to the soil as an organic matter amendment will be very important in meeting the needs of your soil, the microbes, the plants, and your livestock. This experiment is an example of how adding different types of organic matter to the soil can influence soil properties. And in this particular example, water-stable aggregates were measured following the addition of 1% dry matter basis of dairy manure compost, small grain straw, grass clippings, and or dairy manure. And you can see through the application of dairy manure, the level of water-stable aggregates was by far greater than any of the other amendments. So adding an amendment like dairy cattle manure can increase aggregate stability, but you can see in this example, maybe adding compost or straw or even fresh grass clippings, you would not see as significant of an effect. And basically, if you want to look at this from a different perspective, you can see that adding a fresh material like grass or manure, that's what we would consider dead, versus very dead, like compost. Compost has already been partially decomposed. That the microbes will feed on this material probably faster and also break it down, creating more stable aggregates. So again, this is just an example of why it pays and what the benefit is to adding different types of organic matter. All right, the second aspect to building a healthy soil is to make sure you keep the soil covered with living vegetation and or crop residue. This can be done through using cover crops or perennial sod cover, or reducing tillage intensity, or just really having good rotations. It's very important to keep your soil covered. You do not want to lose soil through erosion, because your topsoil is essentially the building block or the foundation of your farm. And so losing soil is not an acceptable practice. So keeping the soil covered is part of building a healthy soil. Now, of course, cover crops, the reason for using cover crops is to cover soil that's normally left bare. And this is very common in row crops such as corn silage, where the corn is removed in the fall, and then essentially, unless a cover crop is used, that soil will remain bare until the next spring when the crops are planted again. So a cover crop is there to cover bare soil. You can also use green manure as a cover crop, and really green manures are used for two reasons. One reason is to keep the soil covered, but the second reason would be to build fertility. They're a green manure or a plant fertility builder, and these would include your legumes such as red clover or white clover, and these crops can be interseeded into row crops to get them established. And catch crops, which also can be cover crops, again, not to make this overly confusing, are generally there to hold leachable nutrients. So again, cover crops basically can be lots of different types of crops. So they can include legumes like clovers, vetch, and field peas. They can also be non-legume crops like winter rye, oats, buckwheat, winter wheat, Sudan grass, annual ryegrass. And again, the type of cover crop you select will really be dependent on what you're trying to accomplish and when. So if you're headed into the fall, and let's say, for example, you've removed corn silage, you may plant a winter rye or a winter grain to cover the soil over the winter. If you're in the middle of the summer and you're trying to provide some soil cover to seed, maybe a late summer seeding or a winter wheat, you may grow a summer cover crop such as Sudan grass or annual ryegrass that will keep the soil covered, suppress weeds, and maybe you can even use it as a forage. There are lots of benefits to cover cropping beyond just keeping the soil covered. They can help reduce fertilizer needs and costs. They can help reduce pests and break pest cycles. They can also improve yields because oftentimes cover crops are doing more than just keeping the soil covered. They're building the tilth of the soil. They're also, of course, preventing erosion and protecting water quality. They can also help conserve soil moisture and just improve the overall ecosystem health. So far we've covered adding plentiful amounts of organic matter of various types. We've covered keeping the soil covered. And then number 3, we need to talk about reducing tillage intensity. Tillage is a practice that will break up that soil tilth and those soil aggregates. And as you break up those soil aggregates through tillage, you obviously are reducing the soil organic matter as well as the structure of the soil, reducing water infiltration and drainage and many other aspects of the soil tilth. And reducing tillage intensity isn't always easy, especially on organic farms where we're growing row crops and there's a need to use mechanical cultivation. But many different systems are in place today, and there's been a lot of new breakthroughs in experimentation with organic no-till. There are many different types of reduced tillage systems. There's conservation tillage, strip tillage, ridge tillage, and then full-blown no-tillage. And all of these have been used in organic systems, and there's examples of them out there through various resources. And of course, we're making lots of strides in organic no-till because we have better planters to plant through thick cover crop mulches and also thick crop residue. One of the most popular ways to implement reduced tillage in organic farming is through the use of a roller crimper, where cover crops are essentially grown and rolled down with this machine here. This is a roller crimper. The roller crimper can either be mounted on the front or the back of the tractor. But as the cover crop is flowering, at this time the cover crop is rolled down by the crimper, and then using a no-till planter, the crop, whether it's corn or soybeans or maybe another crop, is planted into the killed mulch with a no-till planter. And the mulch itself, or the killed cover crop, should be able to suppress weeds and conserve moisture and lead to decent crop growth under a no-till system. Alright, so we don't have much time to talk about no-tillage systems in organic, but hopefully in future sessions we'll be able to do that. There are other resources available that can explain this system in more depth and detail. The fourth aspect to building a healthy soil is using really good crop rotations. Obviously, in an organic system, it is not generally heard of to grow row crops in more than 2 years. And so good crop rotations will help build a healthy soil. If you are growing annual crops, you want to use a rotation that includes both annual and perennial crops. You want to use a crop rotation that has crops with different rooting depths, whether it's in rotation or when the crops are growing, we have different rooting depths. For example, in a pasture, when you have legumes, grasses, alfalfa, etc., creating different rooting depths. You want to have crops that are harvested at different times and have different growth strategies, and therefore potentially suppressing weeds. You want to grow some high residue crops so you can add back to the soil organic matter, and of course you want to have crops from different crop families, again to reduce pest pressure. So crop rotation can improve the soil structure and fertility by alternating both deep-rooted and shallow-rooted plants. And you can just see in this example, these are root systems of prairie plants, not necessarily agricultural plants, but you can see how rooting systems are at different depths. They have different types of roots that may help break compacted layers or just explore the soil profile in a different means and can access nutrients from different levels. So crop diversity from both a root perspective and plant family perspective is very important. Perennial forages are grown on most every single organic dairy farm across this country. I actually can't think of an example where a perennial forage is not grown. And perennial forages, your grasses and legumes such as clover, alfalfa, red clover, etc., are great in a rotation with a row crop such as corn or soybeans or wheat or other crops that would be utilized on a dairy farm. And rotating hay crop or a pasture crop with a row crop has many benefits to this system. And one of the benefits is just better yields. Oftentimes we see a 10 to 15% higher corn yield the year following a hay crop, and this can be attributed to many aspects, such as better soil tilth coming out of a perennial crop. You have nutrients that are made available from the hay crop decomposing, or the perennial crop. And then, of course, you have less weeds, because generally in a hayfield or a pasture, there are few annual weeds that usually cause problems in a cornfield. So following a hay crop rotation with corn or another row crop can generally boost the yields of that row crop. Of course, another benefit to rotating with a perennial crop, especially a legume, is the increased fertility from that crop. So a crop like alfalfa or even an alfalfa orchard grass mix can provide a large amount of nitrogen to the following crop, and we're talking sometimes hundreds of pounds per acre after that crop is plowed down, and providing that amount of nitrogen to the following crop. This is an example of the impact of cropping systems on soil health. And this particular study was evaluating soil health under a cropping system of just continuous silage corn, or a cropping system that has just fescue and alfalfa, so a permanent perennial forage stand, and also a cropping system that had continuous corn silage with the addition of a cover crop. And of course you can see right away that a crop, this permanent fescue alfalfa, that's not tilled, had the highest levels of organic matter, had the lowest compaction, and also had the highest aggregate stability of the cropping systems. You can see obviously that continuous corn had the poorest soil health. There's lots of tillage, there's low organic matter additions to this system, and so the health of the soil would fail much quickly as compared to a perennial cropping system. And then just adding a cover crop to a continuous corn system would help improve the health of the soil. It increases the aggregation of the soil, and it also decreases the amount of compaction and slightly improves the amount of organic matter in the soil. So you can see the value of adding cover crops, adding that organic matter, and also adding a perennial forage crop into a crop rotation system. All right, so number one, again, we've talked about building a healthy soil, adding plentiful and diverse amounts of organic matter. Number two, keeping the soil covered. Number three, trying to reduce tillage if possible. Number four, making sure that you're using crop rotations, especially if you're growing annual crops. Those rotations should be very diverse in both rooting systems as well as crop families to help improve the health of the soil. And then lastly, we just need to make sure that we're reducing nutrient runoff, soil runoff, and also erosion. And there's lots of practices that should be implemented to do this. We can oftentimes see lots of erosion and gullies even in our perennial forage systems. So it's important to understand how to manage our fields to reduce runoff and erosion. And there's, again, many strategies to do this, including grassed waterways, terraces, strip cropping, and several others. So that was a brief overview of strategies that can be implemented to improve the health of the soil. And I think it's obvious just from those top 5 that a multi-pronged approach is going to be the best way to create a healthy soil and ultimately healthier crops and healthier livestock. We have to remember that soil fertility is the ability of a soil to provide a physical, chemical, and biological environment for the plant that is health sustaining. So really we need to remember it's not just about the chemistry and the nutrients, that there's lots of other factors that play into soil health and also crop and livestock health. To wrap up this session, I wanted to briefly touch on monitoring the health of your soil, and really mostly what we recommend is to start with a soil test on your farm. And we use soil tests basically to determine just the level of nutrients in your soil, identify if there's excess nutrients, and use these tests to help balance nutrients in your soil, especially when there's major deficiencies or excesses. And we also use them to monitor soil organic matter and items like the cation exchange capacity. Taking a soil sample is very easy and very important, and it's fairly cost effective for a farm, and it should be done on a somewhat regular basis. For most farms, this is every 3 to 5 years, or maybe when a crop is being rotated. Sampling time really should just be focused on when you have time to do it, but most people prefer to do soil sampling in the fall. Tools that you need are pretty simple and straightforward. Essentially, this requires a soil probe that can be borrowed from the Extension Service, maybe from the Natural Resource Conservation Service, or can be purchased for your farm. Sample size will be determined by the size of the field and the variability in the field. So it's hard to just put a blanket recommendation on the number of soil cores that you would take per field. It needs to be an adequate amount to represent the field itself. Most people choose to walk in a W or an M pattern or some type of zigzag pattern across the field to make sure that you're covering most of the areas in that field. You put each of the soil cores into a plastic bucket and mix the soil in the bucket and take a sample and send that sample to a soil test lab that is appropriate for your region. And this is just one example of a soil test report that's been returned to a farm from the University of Vermont. And you can see the information that it provides. It tells the farm the pH, the level of phosphorus, potassium, magnesium, aluminum, and calcium, and zinc, and other micronutrients in the soil. It also indicates the cation exchange capacity as well as the percentage of cations on those exchange sites. So the percent of calcium on the exchange sites is 86%. And then you can also see this test provides the organic matter level. On most soil tests, it also will provide some lime and nutrient recommendations, and you can see in this case there is no lime required, but there is a need for nitrogen, phosphorus, and potassium, and no need for magnesium. So a soil test can help you mostly with the chemical aspects of your soil. It's a great start, and it will help you key in on some potentially major issues in those fields. It will also help you understand a bit about the soil texture as well as the organic matter in your soils. There are other tests available to actually help you evaluate the overall health of your soil. One example is the Cornell Soil Health Test that's offered as a commercial test to farmers throughout, I believe it's available throughout the country, and it will help you look at the physical, biological, and chemical aspects of your soil and give you a rating for a number of indicators, including aggregate stability and active or the dead organic matter that we talked about. It will tell you where you can make improvements, and then it will provide some recommendations on how you might help to build and improve on those areas in your soils. There are many other field tests like this available in different states, and I encourage you to look into those to help you monitor your soils and the practices improvements that you're making. There are numerous soil resources available to help you learn more about managing soils and soil health, and some of those are listed on this page. I want to thank you for attending Module 2, and I hope that you can join us for future modules in the areas of soil and soil health management.